Okay, Algebra 2 students, it's lesson 10, page 59, Pythagorean theorem. So let's review the difference between properties and definitions. So properties are the way things are. So 3 plus 2 equals 2 plus 3. That's a property. A definition is things that we've agreed on. So like x raised to the negative second power is equal to 1 over x squared, or the order of operations. Those are definitions. Theorem also tells us the way things are, but it can be proved by using properties and definitions. So today we're going to talk about the Pythagorean theorem, which states that the area of a square drawn on the hypotenuse of a right triangle equals the sum of the areas of the squares drawn on the other two sides. So if you look in your book, about midway down the page, you'll see a right triangle that has the sides 4, a hypotenuse of 5, and a base of 3 there. And what it's saying is that the square drawn on the hypotenuse, so that's here. So what you know is that if it's a square, that all sides are the same size, right? Well, this hypotenuse has a length of 5, so that means the side here also would have a length of 5. So that means it would be 25 square units. So the theorem says that the square drawn on the hypotenuse of the right triangle equals the sum of the areas of the squares drawn on the other two sides. So here's a 4. So this is going to be 4 times 4. So this is 16. And this is a 3. So 3 times 3 is 9. So if I add 16 plus 9, that gives me 25. Okay, so we can use that fact that the squares of the other two legs of a right triangle, if you square them, they will equal the square of the hypotenuse in order to find missing sides in right triangles. So we're going to use that to solve for the missing side in example 10.1. The way this is written is c squared equals a squared plus b squared. Now, if you don't remember, the way you can find the hypotenuse of a right triangle is that it's the longest side of a right triangle, and it's the side that's directly across from the right angle. So it's opposite that right angle. So 7 is our hypotenuse, so we would say 7 squared is equal to a squared plus 4 squared. And it doesn't matter whether this side or this side goes first in this equation because you can add in either order. So that'd be 49 equals a squared plus 16. Subtract 16 from both sides. A squared equals 33. That's still not solved. We have to take the square root of both sides of that in order to get rid of that square. So the answer would be square root of 33. All right, let's look at example 10.2. Make sure you've written all this stuff down. I'll leave it up for one more example in case you haven't gotten it written down. All right. Use the Pythagorean theorem to find the distance between 4, 2 and negative 3, 4. Okay, so here what they're doing is they're asking us to put this on a coordinate plane and graph it. And then use the Pythagorean theorem to find the distance. Okay, so I'm going to graph 4, 2. So that's 1, 2, 3, 4, up 2. And negative 3, 1, 2, 3, and up 4. 1, 2, 3, 4. Okay, so there's my line. So what I'm going to do is I'm going to find the right angle where these two lines would intersect if I were to just draw that hypotenuse. That's the distance, right? So we know that this is what we're looking for right here. Okay, now all I have to do is look and see how many units I have. So this is 1, 2 units up, and this is 1, 2, 3, 4, 5, 6, 7 units across here. So my unknown is my hypotenuse, which is the distance from 4, 4 comma 2 to negative 3 comma 4. And then I have a distance of 2 units and a distance of 7 units that I'm going to square. All right, so that's going to be 4 plus 49. So that gives me 53. Take the square root of both sides, and my distance is square root of 53. Okay, I want you to go ahead and try the practice problem. That one, both of the practice problems. The first one, the triangle's already drawn for you, and you just have to find the hypotenuse and plug that into c squared equals a squared plus b squared. And in the second one, you're going to graph these 2 points on a coordinate plane, and then you're going to draw your line between those 2 points and then make your triangle, which, by the way, you can do either way. You could go down to the right, or in my previous example, I could go up and to the left as well, because the units will be the same. The height would still be 2 and the length would still be 7. You would find the distance between those 2 points by plugging the sides into the Pythagorean theorem and solving for C. I want you to go ahead and pause, and then I want you to look and see how you did. All right, so practice problem A, got a side of 5 and a side of A. The hypotenuse is opposite of the right angle, it's 9. So C stands for the hypotenuse, and then A and B stand for the other 2 legs of that right triangle. So it's going to be 9 squared equals 5 squared plus A squared, which is 81, 25. I'm going to subtract 25 from both sides. Which would be 56. And then we'll take the square root of both sides. And I think that they're only asking, let me double check this. 56 is not a perfect square. So it doesn't have a whole number square root. And they're just looking for 56 here. They're not looking for us to reduce it. So square root of 56. Okay. And then for B, we need to graph that on a coordinate plane. Okay, and then we're going to use the coordinate plane to graph these 2 points. So we've got 5 comma 3. So we're going to go to the right. 5, 1, 2, 3, 4, 5. And up 3, 1, 2, 3. And put a point right there. And then we're going to go negative 2 and down 3. Point right there. So that's our hypotenuse of our triangle. So we can draw the triangle on that either here, the right triangle here, or we can draw it here. It does not make any difference at all which way you draw it. Count the units, 1, 2, 3, 4, 5, 6, 7. So there's 7 across. So the horizontal units are 7 and the vertical units are 1, 2, 3, 4, 5, 6. So to put that into the Pythagorean theorem, it's going to be, C squared, because that's the hypotenuse, equals 6 squared plus 7 squared. Okay, so 36 plus 49 is 85. Take the square root of both sides. And let me double check the answer, make sure they're not looking for us to reduce it. Yep, so just square root of 85. Okay, hope you did well with that.